Previously, we learned to edit source code and add statements to manipulate the behavior of crab objects in the little crab scenario. We also learned the basics of decision-making using the if statement to decide what code to execute under the given circumstances. As of now, the crab constantly moves 5 pixels to the right. When it's at the edge of the screen, it turns 17 degrees clockwise. For fun, let's make the crab turn randomly as it moves right, even when it is not at the edge of the world. To do this, we can use the method getRandomNumber included in the Greenfoot library. To see the specification for this method, we visit the Greenfoot documentation. One way is to go to Help in the File menu, then click Greenfoot Class Documentation. Since getRandomNumber is a part of the Greenfoot class, click this class name to see it. The Greenfoot class has many useful methods we'll use throughout the course. Scroll down to getRandomNumber. The description reads, return a random number between 0 inclusive and limit exclusive. Inclusive means including 0, and exclusive means excluding the limit. For example, if limit is 50, getRandomNumber will return 0 through 49 at random. Look at the parameter. This is where we determine the range of random numbers. Since limit is an int, we give it a whole number representing the limit. The return type for getRandomNumber is int. This means it will return a whole number representing the randomly generated number, again determined by the limit. Now, let's say we want the crab to turn 10% of the time. A percent is some number out of 100. That can be 100 of anything: houses, cars, people, even random numbers. 10% is 10 out of 100. For example, 10 houses out of 100 houses, 10 cars out of 100 cars, even 10 random numbers out of 100 random numbers. So if we designate 10 numbers as ones that will trigger the crab to turn and generate 100 random numbers total, that will equate to the crab turning 10% of the time. We call getRandomNumber with a limit of 100, which causes it to generate numbers 0 through 99. To make it easy, we can say numbers 0 through 9 will be the numbers that trigger a turn. 0 through 9 is a total of 10. So out of the 100 numbers generated at random, 0 through 9 cause the crab to turn, 10 through 99 do not. Let's see how we implement this. First, this calls for decision-making. If the current random number is one of 0 through 9, the crab turns. We'll have it turn 45 degrees clockwise. Again, we use an if statement. The less than symbol is what we call a relational operator. It works just like it does in math. Less than 10 means any number from 9 on down. This is exactly what we want, since we said 0 through 9 make the crab turn. What if we put less than 9? Then 9 would not be included, which is not what we determined we want. Be careful of logical errors like this. Less than 10 also includes all the negative numbers below 0, but since getRandomNumber won't generate numbers below 0 in this case, it doesn't matter. Here's a list of relational operators. They work just as expected from basic math, although some appear differently since they have to be typed on a keyboard. Back to the documentation. Notice that getRandomNumber has the keyword static in front of it. In fact, all methods in the Greenfoot class have static in front of them. We call these class methods. Later, we'll discuss this in detail. But for now, know that it means we put the name of the class in front of the method when we call it from within our source code. So anything from the Greenfoot class will be preceded by the class name, Greenfoot. We also put a dot, known as the dot operator, between the class name and the method name. It works as a sort of separator between the class name and the method name. 100 inside the parentheses represents the limit, which will generate numbers 0 through 99. This is a good time to point out the difference between an argument and a parameter. When we look at a method header, what is inside the parentheses is known as a parameter, as we already know. When we call a method, what appears inside the parentheses is known as an argument. This is just terminology, but it helps programmers communicate with one another. Back to the crab. Currently, the crab turns 10% of the time, but always by the same amount and always clockwise. Let's make it more realistic by randomly determining the degrees and direction of turn. We can easily solve the problem of turning the same amount each time by using getRandomNumber a second time. Here, the argument of 45 generates values 0 through 44, meaning the crab will turn clockwise up to 44 degrees. However, 0 really isn't very useful, is it? If we execute turn 0, the crab doesn't actually turn. What we really need is to generate numbers 1 through 45 inclusive. To do this, we have to think like problem solvers. If an argument of 45 generates 0 through 44, what can we do to change those to 1 through 45? The answer? Add 1 to each generated number. Think about it. If getRandomNumber returns 0, 1 is added to that so the crab turns 1 degree. If getRandomNumber returns 44, 1 is added to that so the crab turns 45 degrees. It's important to note, the addition occurs inside the parentheses before turn actually executes. This is precisely what we want so the crab turns the correct amount. Also, make sure the +1 appears outside of the parentheses for getRandomNumber. We generate the random number first, then add 1 to it, then call turn. So we still have the problem that the crab only turns clockwise. We could add a second similar if statement that makes the crab turn counterclockwise. However, there's a simpler solution to this. Let's say we want the crab to turn up to 45 degrees clockwise or up to 45 degrees counterclockwise. This is a total of 90 degrees, but if we account for 0, it actually totals 91. GetRandomNumber 91 returns numbers 0 through 90. Knowing that positive values turn the crab clockwise and negative values turn the crab counterclockwise, what can we add or subtract so the return numbers are -45 to +45? Well, 0 minus 45 is -45. 90 minus 45 is 45. This is just what we need. Now, this isn't totally accurate. For example, if the random number is 45, that leaves us with an argument of 0 for turn, meaning the crab won't turn. There are easy ways to fix this, but we need to progress a little further before learning how to do that. This is accurate enough for now. Let's add a completely different animal to the scenario. We'll make it a worm and later make it so crabs eat worms. We want to add a new subclass under Actor. Right-click Actor, then select New Subclass. In the dialog that appears, enter the new class name Worm. Worm is a good descriptive name for the class. There's no mistaking what it's for. Be sure to capitalize the W, as Pascal case is the convention for class names in Java. Next, click the worm image. This assigns the image to objects of the worm class. Click OK. Notice the worm class is added to the class diagram. We add worms to the world just as we've added objects before. When we run the scenario, the crab moves around as before, but the worms do nothing, not even when a crab runs into one. Let's program the behavior to make crabs eat worms. We'll make it so when a crab runs into a worm, it eats the worm. The first thing we should do is look for pre-existing methods that will help us accomplish this. Nothing is in the crab class to determine when a crab is touching a worm, so we work our way up to the actor class. Let's look at the class documentation for the actor class. Scrolling through the list of actor methods, we see isTouching and removeTouching. isTouching determines whether the current object is touching another object. The parameter looks a lot different from what we've seen so far, but it just means isTouching expects a class as an argument. We will specify the worm class in this case and write the argument as worm.class. This works with any class. Write the name of the class followed by .class. Notice the return type is Boolean, meaning we can use it in the condition of an if statement. The other part to this is to remove the worm if the crab is touching it. Remove touching has the same type of parameter. It's also a void method, meaning it's just a command to remove the object from the world. Putting all of this together, if the current crab object is touching a worm object, then remove the worm object. Of course, this code goes in the act method for the crab class since we want to determine if a crab is touching a worm. When we run the scenario, we see that when a crab runs into a worm, the worm disappears. So far, we've placed all of our crab code in the act method for the crab class. Rather than put all of these crab behaviors in the act method, a better way is to compartmentalize each behavior into its own method that can be called when needed. Let's take the code we just wrote for locating and removing a worm and move it into its own method. Here is the new method definition. The name of the method is lookForWorm. It can be most any name, but one that describes the purpose of the method is best. When we see the name lookForWorm, it's very clear what this method does. Method names in Java are written in camel case, where the first word is all lowercase and each subsequent word begins with a capital letter. Also, there are no spaces in the name. Notice the method header begins with public. All of the methods we create for now will begin with public. We'll discuss this in detail later. Also, this is a void method. It just looks for a worm and removes it. It doesn't need to return anything. Further, the parentheses are empty since it doesn't need any additional information to do what it does. The method body simply consists of the code that was previously in the act method. This method is outside of the act method, but within the crab class. All methods we define will be placed within a class, but never inside of another method. So far, we have only defined the method. The method only executes when it's called. To call it, we'll put code in the act method. Remember, the act method drives the behaviors of a crab. To call a method, simply write the method name, parentheses, and arguments if it takes any. Wherever the call is placed is where the method will execute. In this example, it doesn't really matter where we place the call, so long as it's directly within the act method. Note, moving the code to a method does not make a crab behave any differently. This is simply a means of making the code neater. We can also add comments to the method describing what it does. We've seen single-line comments that begin with 2 forward slashes and comment out a single line. These shown here are multi-line comments, which begin with slash, asterisk, and end with asterisk, slash. They can be used to comment out multiple lines at once. Everything between these sets of symbols is considered a comment and ignored by Java. Looking back at the act method, we see 2 other chunks of code that perform specific tasks. This is the perfect opportunity to create additional methods. The first chunk determines what to do if the crab is at the edge of the world. We could create turnAtEdge, which is exactly what the first if statement accomplishes. We can place a call to turnAtEdge in the act method where the code was previously. We can also create random turn, which is what the second if statement accomplishes. Let's add another animal to our scenario, a lobster. We'll make lobsters eat crabs the same way we made crabs eat worms. This is so easy now. We can reuse most of the code from the crab class. First, let's copy the crab act method and the methods we defined over to the lobster class. Now all we have to do is find any reference to worm and change it to crab. Let's turn this into a single-player game. We'll make it so the player can control the crab looking for worms and avoiding lobsters. If we return to the Greenfoot class documentation, we find isKeyDown. This method determines if a specific key on the keyboard is currently pressed. If it is, it returns true. Notice the parameter is something we have not seen yet. This parameter indicates isKeyDown expects a string argument. String is a Java data type similar to int and boolean we've seen so far. A string can consist of letters and many other things. For now, the strings we use will be surrounded by double quotes. isKeyDown expects certain strings. If we scroll to the top of the documentation, we see examples of how these are to be written. For example, if the lowercase a key is pressed, we write isKeyDown A. To determine if the right cursor key is pressed, we write isKeyDown Right. To begin, let's remove TurnAtEdge and Random Turn from the crab class. Since the player will control the crab's movements, these methods are no longer needed. Next, we'll define a method called checkKeyPress that checks for key presses. We'll check for left and right cursor keys, making the crab turn left and right. Again, since isKeyDown is a member of the Greenfoot class and begins with static, we call it by preceding it with Greenfoot and the dot operator. We'll leave the move method as is in the act method so the crab constantly moves, but we could easily add player control for this as well. Another thing we can do to improve the game is to have it stop when the crab is caught by a lobster. Going back to the Greenfoot class documentation, we find the stop method, which stops execution of the scenario. So where do we put this method call? We want to stop the game when a lobster catches a crab. Where in the code does it test to see that a lobster has caught a crab? The look for crab method. If a lobster is touching a crab, remove the crab, then stop the game. All good games have sounds, so let's add sounds to ours. Looking in the folder for the little crab scenario, we find a sounds folder. In that folder are sound files included with the scenario. We can even add our own sound files, but these are fine for now. Greenfoot can play several sound file formats. In the Greenfoot class documentation, we find Play Sound. Clicking on the name gives more detailed information. First of all, the parameter is a string named SoundFile. The string we give it is the name of the sound file we want played, making sure the file is in the correct location. This is usually the sounds folder for the scenario. Let's have our game play slurp.wave when a crab eats a worm. Where do we place the play sound method call for this? Where we determine a crab has eaten a worm, in the look for worm method. Let's have our game play AU wave when a lobster eats a crab. That goes in the look for crab method. But be careful, the call to play sound has to be placed before the call to stop, otherwise the game will stop and the sound will never play.